This lesson is going to look at the basic properties of exponents. So looking at the properties of exponents, we know that an exponent, right, has two parts. The first part of the exponent is the base, or the big number, and then the power, or what you commonly think of as the exponent, is a little number, and that tells you how many times to multiply that number by itself. So if we're looking at 2 to the 4th power, that means 2 times 2 times 2 times 2, which is 16. 2 to the 3rd power is 2 times 2 times 2, which is 8. 2 to the 2nd power, we sometimes call that 2 squared, is 2 times 2, which is 4, or 2 to the 1st power is just 1, 2, so that is 2. So if we're looking at that answers in terms of a pattern, we notice that it is being reduced by half, or being divided by 2, as the number of the exponent goes down 1, because it goes from 16. Half of 16 is 8, half of 8 is 4, half of 4 is 2, etc. So if we continue the pattern and we go down an exponent, so 2 to the 1st power, if we go down, that would be 2 to the 0 power. And if we still continue the pattern by cutting in half, 2 to the 0 power would equal 1, and that brings us to our first property. Any number that's not 0, that's raised to the power of 0, is always equal to 1. Anything to the 0 power always equals 1. If we continue the pattern and we continue bringing the exponent down and continue taking half of what is left, I have -1, -2, and -3 as my exponents, and if I continue taking half, 2 to the 0 power was 1, so half of that is 1/2. And then if I continue taking half of a half is a fourth, so 2 to the -2nd power is 1/4. And then if I take half of that, I get an eighth, so 2 to the -3rd power is 1/8. So what happens with negative exponents? Negative exponents take the regular exponent as if it was positive, and it puts it on the denominator of a fraction. Because if you notice, 2 to the 1st power was just 2, 2 to the 2nd power was 4, and 2 to the 3rd power was 8. So it just took those values, leaving them positive, and put them on the denominator of a fraction, and put a 1 on top. So some of the properties of exponents. The first one is product of powers. Notice your bases are the same. So we have 2 squared times 2 cubed, or 2 to the 3rd power. So 2 squared is 2 times 2, and 2 cubed is 2 times 2 times 2. So if we are multiplying all of those together, how many 2's do we have now? We have 5 of them. So the trick is to leave the bases the same, but to add the exponents. So I would have 2 to the 2 plus 3 power, which is 2 to the 5th power, as there were 5 2's at the end. The second property is the power of a power. Notice that you have an exponent on the inside of parentheses, and that entire thing is being raised to another power. So what that would really mean would we take the base, which would be 3 squared, and we'd multiply it by itself 3 times. It would be 3 squared times 3 squared times 3 squared. 3 squared means 3 times 3, so it'd be 3 times 3 for the first one, 3 times 3 for the second one, and 3 times 3 for the third one. Now, I have how many 3's? 6. And what did I do with the original exponents to get 6? I would have taken 2 and multiplied by 3, so it would have given me 3 to the 6th power. The product of a power. So if you have a multiplication problem, a product inside of parentheses, and that product is being raised to a power, I can take each individual part of the product and raise it to the power before I multiply it together. So for example, 2 times 3 to the 4th power is the same thing as saying 2 to the 4th power times 3 to the 4th power. The fourth product, or the fourth power property, is the quotient of powers. So let's look at 3 to the 7th divided by 3 to the 3rd. Remember when we had a fraction? If I had a fraction like this, 3 over 3, right, in an equation, that's simplified by canceling each other out. So I can do that as many times as I can here. So I can cancel out that set, I can cancel out that set, and I can cancel out that set. How many am I left over? I'm left over with 4 of them, right? So my answer is 3 to the 4th power. So what would I have done with my 2 exponents to get 4? The answer, because I'm making those pairs and taking those pairs away, is subtract them. So I keep the base the same, and I subtract the exponents. Now, this looks a little bit complicated, but remember, as we said in class, we want to take each individual piece and separate them before we put them back together. So I'm going to take the 2's and separate them, the x's and separate them, the y's and separate them, and the z's and separate them. So if I did the 2's, I would have 2 to the 5th power over 2 squared. Remember, when we're doing the division, the base stays the same, so it stays 2, and then my exponents I subtract. So 5 minus 2 gives me 3. So I would have 2 to the 3rd power. Notice that there are more on top, meaning that the 3 is positive. So because the 3 is positive, it stays on the top of my answer. So notice up here in my answer, the 2 to the 3rd power is on the top. And I really could simplify that to 8 if I so chose. So I really could have simplified, because 2 to the 3rd power is one that you should know. I could have simplified that even further to say 8x to the 3rd, z to the 5th, over y to the 3rd. Okay, so then if we're focusing on the x's, I can take those and separate them out as well. So I would have x to the 4th power over singular x. When there's no exponent, we assume that the exponent is a 1. So then I would have my base stay the same, it stays x, and then my subtraction problem would be 4 minus 1, which gives me 3. So I would have x to the 3rd power. Again, because there's more x's on the top, and the 3 is positive, the x stays on the top in my answer. Then I would do the z's, or the y's. So I would have y to the 7th over y to the 10th. My base stays y, and my subtraction problem becomes 7 minus 10, which gives me y to the negative 3rd power. Because that 3 is negative, remember, any negative exponent sends the positive version of it to the bottom. So my bottom, or my denominator of my answer, has y to the 3rd power. And then lastly, I would do the z's. I would have z to the 5th power divided by nothing. Right, there isn't anything down here, so it would just remain z to the 5th power. And then it's on the top, so there it would stay in the top. So my answer is either 2 to the 3rd power, x to the 3rd power, z to the 5th power divided by y to the 3rd power. Or because I know what 2 to the 3rd power is, I could have simplified it to say 8x cubed z to the 5th power over y cubed. The last power property is a power of a quotient. If you notice, you have a division problem, that's what a quotient is, raised to a power. A division problem is basically essentially just a fraction. So for the first example, we have 2/3 to the 2nd power, or 2/3 squared. What the power of a quotient property says is that you can take each piece of your division problem and you can separately raise it to the power. So instead of 2/3 to the 2nd power, I could say I have 2 squared over 3 squared. And I can simplify both 2 squared and 3 squared, as those are ones that we should know the values of. So 2 squared is 4, and 3 squared is 9. So my answer would be 4/9. The only other thing that we would have to check at this point would be to see if we could simplify the fraction. Since there are no common factors besides 1 for 4 and 9, that fraction is simplified as far as it can go. So my final answer there, in as simplified form as we could get it, would be 4/9.